Okay, here we go. I'm going to call this one Let's Make an R Package. So, assuming that you've got R open, just to open to nothing, really doesn't matter. Assume you got a terminal open, and other than that, you may want a browser open, obviously. And I would suggest Hadley Wickham's R package page. So the first thing you want to do is make sure you have all the packages that are going to help you develop R packages without going through the really hard way of doing it. All these were done by RStudio. So we'll look at the command that we want to do for that. So we're going to install packages, DevTools, Oxygen 2, which will do automatic documentation, test that, which will do unit tests for us, which I discovered that to pass CRAN you must have tests. I don't know that that means any specific kind of test, but there must be some kind of test, I guess, for every function. And finally, Knitter for generating documentation, PDFs, HTML. So I'm going to skip this step since I already have these things installed. Let's see, so we've got DevTools, all that good stuff. So from here, we just want to go up to File, and we want a new project. If you're not using projects, I suggest that you do. Projects are nice that when you open a project, it puts you in the directory of the source files that you're working on, so you don't need the set wd command, which I don't think I've ever used, ever. It's not recommended, and it's very specific to your particular computer, and you don't want to just tell people they have to edit it. You can do that, of course. Anyway, let's go to new project. This is about the only way to do an R package. So I'm going to put this in a new directory. One of our choices here is an R package. So let's do that. It's a package with RCPP. That's a new thing I didn't know. And if you're going to use CPP to implement your algorithms, I guess it automatically includes all the stuff you need for compiling C++ and including it in shared package library. So we need to give our package a name. What should we call this? I'm just going to call it In Silico. In Silico. If you've got a bunch of source code like I did with Trang's project that's going to be used in this new project, you can go ahead and include those here, especially if you already have those as functions. And then what directory you want to make this a subdirectory of. So that's, in my case, I put everything that's version controlled, which is code that I've written, other than analysis code, goes under Git. So we've got Git there. We're going to tell it to go ahead and create a Git repository, even if we're not, quote, using it for team development or any of that. It's kind of nice for version control. It stays local on your machine. You don't have to worry about it. Packrat's interesting. Packrat is a way of packaging all the stuff that your package is using at the moment it was put together. So all the dependencies and everything's exactly like the development machine. But then you have to have something on the other side that knows what this Packrat thing is, which for RStudio it does know. So Haven't tried that. Only read about it. Sounds interesting, but here we go. Create a project. So we got a new window open here. And what have we got? We've got one function called hello. Hello world. Prints hello world, classic first thing. If you look over here, it created a directory structure, folder structure if you're not a Unix person. And we've got some things in here already that are handy that you may or may not know about. The big thing is an R directory for our R code and a man directory for the man pages, the documentation pages that will get created for us with Oxygen. So in order to make that happen, I think we have to go to set our project options. Let's see, build tools. Here we go. So it's off by default. Generate documentation with, I call it Roxygen, R Oxygen. And we're going to have it automatically create RD files of the function file, function documentations. The namespace file is your dependencies. I didn't know about generating vignettes. Sounds like a good idea. We won't worry about that for now. And when does it get run? So we'll just leave that as is. Now we're ready to go. So we should be able at this point to go up to build, say clean and rebuild. And the package has been built. Doesn't really do anything. You see over here in the corner that when a package gets built, in RStudio at least, it knows to reload it because you don't want cached versions of your functions residing in memory, the ones you're developing. You want the latest updates. So all you really need to do at this point, let's take a look under the R directory. There's a hello.r here. This is the file we're looking at. So hello is a part of our library. So we should, since the library is loaded here, just say hello, and it says hello world. So we've implemented a function in a package. That's all there is to it. Now, can't be all there is to it, obviously, but that's enough to get a package up and running. You can even build it as a package that you could distribute. So I'll build a source package since it's just R code. See over here that it gets built. Goes into a file called in silico, the version number, tar.gz. This is a file I send you guys sometimes when I get something where I think I want people to look at it. I'll go ahead and say build and build the source or binary package here and distribute it. Then on the other end you can go over to tools, install packages, and go over here and say I want to install a package not from a repository but from a tar.gz, what we call a tarball. So that's it. So other than documenting the function, which this function doesn't have really any documentation for it, I can open a project in another window and show you what private EC is looking like. Let's see. Go. Get private EC. Open the project file. You can see here we have a function. Let's get a better one. That's an internal function that's not meant for other people to call. Here's the actual private EC function. So break this out a little bit. It obviously takes quite a few parameters, and it's going to return some things for us, so we need to document that. So these are special comments. You'll notice that's comment character with an apostrophe or a single quote. And that means this is an Oxygen documentation. So for parameters, we have this @param, the name of the parameter, and then some description of it. From what I read, they recommend saying, what data type do you expect? Say that somehow. There's no strict way of doing this. And then what it's used for. And we just do that for all the parameters. Then we say, okay, we're going to return something. I'm going to return a list. And here you could just say, I'm going to return a list with, description of what you want to do. But I went a little bit fancy since I learned this new command called describe, which is very much like the HTML, but not quite. This is R Markdown. And I just made a little list here that has basically it's a dictionary list. Here's the word and here's its definition, each in curly braces. Here's where we can put some examples. Unless you do something special, these examples have to run. So when you go up to build a package and you say, I want to check this package before you try to send it to CRAN, or to ensure that it's passing all the most stringent things you can check, it's going to check that. It's going to try to run that code, and if that code doesn't run, it's going to give you an error, or at least a warning. We can put notes in here. There's just a little note about how we pick certain parameter values by default. We've got a reference here to the paper we did, in which this function was used. You may have a family of functions. It's a way of making a set of functions that are all related somehow. So I call everything in this package classification functions. I call the file classification.r. These are just conventions. You could call it privateec.r, which I guess that's not recommended. That's what you do to document the package itself. But give us some name for grouping of functions. Or you could just say put all my functions. Put them all in this file. If you don't know yet, you can move through the files in the function down here on this little click box. There's stuff to click everywhere in RStudio now, so almost everything you click on does something. So you can look, we can go through these. Here's the original threshold out function that's written to compare to our new method. It's got a bigger example, some parameters. So we'll switch back over here. So if you're going to write a new function, I suggest you grab a copy of Private EC, and when you install it, it gets put into a directory under your home directory if you don't have access on the system to go into a shared directory for everybody. Or you can just use your archive manager to open it up and untarz it, sort of like unzipping. So you can unzip it and you can see the structure that we had over here in our file system for the package. You can see the source code to the files. So basically when you get a package, a source package, you get everything. You can look at everything. There's nothing hidden, it's all open. So that's pretty nice. Like I said, we just want to keep adding functions here. I have another package called RIndex that's it's basically everything but the kitchen sink of our in silico lab functions. It's needs a little work, needs to be polished up a little bit. It's sort of in a, well, I don't know, I haven't looked at it in a while, maybe in better shape than I give it credit. Okay, so this is, I'll call this our first video. It's enough to get you started, at least to write one little function. Just use the one that's in there. Some helpful hints here for using keyboard shortcuts. I suggest that. Might get into unit tests next time. Unit tests are fantastic. I've been avoiding it all my life. Just by trying to rationalize it. I only need it if I'm working on a big project. But if you're just writing one function and you're changing it over time, you want some way to know, is this function still working after I made those edits? And you can write your own little test function here and there, but it's nice to have one you can go back to and just say, run all my tests, all my assumptions about what this package function should do. Okay, so we'll call it an end there. This is probably big enough already anyway. It's going to be a big upload. I'll put this on YouTube and share it with you. Hopefully go back and reference if you need, or pause or whatever to get started. This is a fantastic way to do it with RStudio now. It used to be a real pain. You had to start all these files and stuff by yourself, make the directories, create these files. Speaking of which, I'll show you one last thing, the description file. You had to create this thing. But basically it just fills in things from our little wizard that created the package for us, and obviously need to go in here and edit these things to what's specific about your package. The license it's under. I generally use GPL3. It's the latest general public license from GNU. And although there's others, community license gives it sort of a public domain kind of thing. Anyway, you want to fill this out, and as you do things, and as long as you use the DevTools functions, and you can read about them again on Hadley Wickham's our packages book page. He puts his whole book online, his O'Reilly book. And if you use his tools, it'll add things here when they need to be added. So that's pretty handy. And the format of this thing is very picky, so you don't want to mess around too much with it. I'll just leave it alone. Use the DevTools. For instance, if you want to add a vignette, you could go up through the venues and say, I want to add a vignette, put it in, but then you have to let the package know. Don't really want to do that the hard way, I guess is what I'm trying to say. So basically you say here, create vignette. If there's not already a vignettes directory, it'll create one for you. And you can just keep using that function to create vignettes, and it'll create a vignette with just a template, boilerplate, for going in there and just edit out everything but the basic body of it, and you can start from there. Anything else? In your implementation of functions over here, if you need to use an external library, say you're using glmnet, you don't want to include it here, like library glmnet. Don't do that. You don't want to do that. And don't use my little always do this idea of an RM here with an ls to remove everything in the environment, to clear everything out. You don't want to do that here either. This is a package. It's running for somebody else, and they're loading it through the library mechanism, and that's not anything like just a basic script. So don't be tempted to do that. I think it still runs okay if you do it, but you're not going to pass the test. It's going to let you know don't do that. And if you do that, it makes it harder for people to know what do I need to have to run your package. Let that dependencies file in this description over here, done through the DevTools, handle that automatically for you. Let RStudio do all it can for you. It's amazing. It'll save you untold days of work. Okay, so we'll go through test functions maybe next, adding vignettes, how do you document the package itself, all these things I've sort of learned the hard way. Google searching, Stack Overflow, you know the general procedure for doing this kind of thing. So I'll let you benefit from my knowledge, and I'll keep this one short and let you go. See you later.